All right, here we go. Module 6, Lesson 13, Video 3. And we have our beautiful picture here, right? And our 4 colors, and we're ready to roll. Now we're going to use a straight edge to draw a dashed line that's parallel to the x-axis and intersects the y-axis at 5. Okay, and you could use black or whatever color you want, because we're going to have another line of symmetry, and it's going to be at 5 going across. Okay, and it's going to be dashed going across. There we go. And it is a line of symmetry. It's going to go on forever, so it's going to have arrows on the end, unlike our line segments, right? Okay, how many units above the horizontal line of symmetry is point K? 1, 2, 3, 4, 5, right? 5 units above the horizontal line of symmetry. Show your partner where we can plot point L so that points K and L are symmetric now with our horizontal line of symmetry. Okay, so if that's 5 above, 1, 2, 3, 4, 5, then our L is going to be 5 below. 1, 2, 3, 4, 5. Right down here, L. Okay. I don't know what color I'm supposed to be using. It's all right. Use whatever color works out for you. Okay. What is the ordered pair for point L? How many units below the line of symmetry is point L? Okay, we already said 5, right? And it is 5, 0, because it's right there on the bottom. So we're not going up and down at all, right? Compare the movement from point K to point E with the movement from point L to point F. Okay, so K to E, you could go 1, 2 down and 1 to the left. And L to F, here's F. So 2 up and 1 to the left. I mean, there's different ways to do it, right? Okay, what do you notice about the movement from K to E compared to L to F? Down and left, up and left, right? Okay. And verticals are opposite. One is down, one is up. And horizontals are the same. Okay, very good. Show your partner where we can plot points M and N so that they're symmetric to points A and B with the horizontal line as the line of symmetry. When you and your partner agree on the locations of M and N, go ahead and plot them. And M and N need to be symmetric to A and B. Okay, so here's A. Now we're using the horizontal line, right? So that means that M is going to be 1 down because A is 1 above, right? And that means that N is going to be 1 down because B is 1 above. All right. How many units? Okay, we already said 1 above, 1 below. And let's look at a chart. Now we have above horizontal line of symmetry and below horizontal line of symmetry. And what do you notice? Now your x's are the same, right? Before your y's were the same. Now your x's are the same, right? 5 and 5, 2 and 2, 8 and 8. Okay, very good. Each point above the horizontal line of symmetry has the same x-coordinate as the symmetric point below the horizontal line of symmetry, which means the symmetric points lie on the same vertical line. Okay, awesome. And now we're going to use our straight edge to draw. And we're supposed to use the same color that we used for line AB. So I'm going to be using my second color. I'm going to use black. How about that? And we're going to draw a vertical line segment from point A to the horizontal line of symmetry and a vertical line segment from point B to the horizontal line of symmetry. Okay, so just like this, down to the horizontal line of symmetry. Okay? Now think about how you could connect points A, B, M, and N to create a polygon with a horizontal line of symmetry. Do you see it? Hopefully you're starting to see another polygon here with the horizontal line of symmetry, so you could fold that rectangle in half, right? Okay, very good. Okay, and we have some more directions. Are you ready for more directions? I know, sometimes we have to go fast, but try not to have too many videos. All right, plot and label point O so that points C and O are symmetric and the line of symmetry is horizontal. Plot and label point P so that points D and P are symmetric and the line of symmetry is horizontal. Use a straight edge to draw OP, and use the straight edge to connect points to create a polygon with vertices CDOP. All right, you can pause me and do it if you haven't done it yet, or we can do it together. Okay, plot and label point O so that C and O are symmetric. Okay, so here's C, so we want O to be symmetric across the horizontal line. So that means this is 2 above, so O is going to be 2 below. 2 below, not 3 below. There we go. 1, 2, 1, 2. So this is O. Very good. And then P, same thing with D. I told you it was going to be quite the art piece, right? And now we're going to draw OP. Oh, yeah. I made that D. I should have made that P. There we go. Hello. Okay, OP. Very good. And now CDOP. Wow. Pretty cool. All right. What do you notice about polygon CDOP? One, two, three, 4. Okay, they're both 4. How about these? Also 4. 1, 2, 3, 4. So both sides are the same length of 4, right? So that makes it a square in the middle there, right? Still has right angles. Okay, 4 right angles. Horizontal and vertical lines of symmetry through the midpoints, because it's right in the middle, right? You see that? Okay, so far the entire graph is symmetric with the line of symmetry when the line of symmetry is vertical. What other segments can we draw so that the entire graph is also symmetric when the line of symmetry is horizontal? Okay, so you see that? If we use our vertical, then everything is the same so far. But if we do horizontal, everything is not quite the same, because we also need to add JM and IN and an angle down here, FLH. Okay, got that? I know, how pretty. Okay, I'm going to keep going instead of making another video. We just have a little bit more to end to finish up, so stay with me and make this thing so beautiful. Okay, one more set of directions. In any color. All right, I'm just going to do it with you, but if you want to pause me here and go ahead and do it by yourself, you can. Plot and label point Q at 1, 9. Okay, 1, 9, Q. Very nice. Use a straight edge to draw AQE. A and E all the way up to Q. Okay. Plot point R and draw BRQ so that AQE and BRQ are symmetric with the line of symmetry is a vertical line. Okay, so that means that R is going to be over here. So 1, 2, 3, 4 to Q, 1, 2, 3, 4 to R. Yeah? Okay, and then BRQ. No, BRG. Yeah, BRG, not BRQ. Because it's going to be symmetrical to this. Yeah, there we go. It's like a quilt design or something. Plot point S so that MSF and AQE and MSF are symmetric to the line of symmetry that is a horizontal line. M, S, F. See F and M. Yeah, so we're going to put our S. Q is 1, 2, 3, 4 above. So 1, 2, 3, 4 below is S. And then M, S, F. I don't know. Seems kind of fun. Okay. And then T, so that NTH, angle NTH, I can see it here, is symmetric with the line of symmetry that is both these two. It's going to be symmetric with both of those. Okay, so S is 1, 2, 3, 4. 1, 2, 3, 4 to T. And NNH. So angle H, T, N. There we go. Wow. All right. And we have one more chart. Points left of the vertical line and points right of the vertical line. And we can see that our x's are the same and our x's are the same there. Okay. Wow. Quite a thing. And depending on what you're doing, you might want to color this and design a quilt square or design a park or make something cool. Yeah. And when the line of symmetry is horizontal, why do symmetric points like Q and S have the same x-coordinate? Q and S have the same x-coordinate, right? Because they are going across the horizon. They're the same distance apart. And when the line of symmetry is vertical, Q and R have the same y-coordinate because they're the same distance on either side. All right, well, there's a lot you could think about with this. Thanks for sticking in there for the extra long video. I appreciate you guys. Have a great day. Aloha.